So let us begin with the second problem in this series, and the problem is 3.2. The problem is stating what would be the interaction force between two copper spheres, each of mass 1 gram, separated by the distance 1 meter, if the total electronic charge in them differed from the total charge of the nuclei by 1%. So to approach this problem, let us first of all understand what exactly the problem is stating. So we need to understand that there are two copper spheres involved which are considerably small in size and separated by a certain distance, the distance being equal to 1 meter. So I'm putting over here as r right now, which we will put as 1 meter, and over here I'm writing r equals 1 meter. Now this copper sphere is of mass 1 gram, so it is having a mass equal to 1 gram, and again over here it is having a mass equal to 1 gram. The charge on the sphere is not given directly. The charge on the sphere is being stated to be having a value which is equal to 1% of the nuclei charge. So if I consider the problem by starting it this way, that the gram molecular weight of copper, and it is being equal to 63.5 gram. So we are having 1 gram, so we can say therefore moles of copper. So moles of copper can be calculated as given mass by molecular weight. So this is the moles of copper. Now the total number of protons present in it, which will give us the value of nuclei charge. So we can say that it is equal to 1 upon 63.5, that is the number of moles that we have. Now we calculate the interactive atoms, which is equal to 6.023 into 10 to the power 23 atoms, and hence 6.023 into 10 to the power 23 nucleus, and followed by this we multiplied with 29, that is the atomic number, followed by the charge of each proton 1.6 10 to the power minus 19. So this is the total value of the charge that is present inside the nucleus of the copper, and the problem is asking us that it is the 1% is given to the sphere. So if 1% is given to the sphere, so therefore charge on copper sphere which are treated as point object, that is equal to 1% of nuclei charge. So we can calculate this value as Q equals 1 by 63.5 times Avogadro number 6.023 10 to the power 23 times atomic number times 1.6 10 to the power minus 19 multiplied by 1 by 100. So this will give us the 1% of this value in coulomb. So over here we get this value as 4.3 multiplied by 10 to the power 2 coulomb. So as such it is a large value. 1% of the nucleus charge is giving us a value 4.3 into 10 to the power 2 coulomb. Now we calculate the force between these spheres. So using Coulomb's law we can say therefore force between the two sphere. So this can be written as 1 by 4 pi epsilon naught q square by r square. So if we substitute the values, so we can say that the force of interaction is 9 into 10 to the power 9, charge squared 4.3 into 10 to the power 2 squared, and the distance between them being equal to 1 meter, so 1 square. So on substituting the values and calculating, we get a value equal to 1.7 into 10 to the power 15 Newton. So it is quite a strong value of force that we are getting, which we can write as 2 into 10 to the power 15 Newton as per significant figures. So this is the final answer to this problem that we have.